My name is Jacob Tarts. I'm a PhD student in mechanical engineering, and I'm going to present on radio frequency heating for sustainability. It's no secret that carbon emissions are killing our planet. Sea levels are rising, weather patterns are deadlier, and species are going extinct. Moreover, as we build new infrastructure to protect humanity from these effects, we produce more emissions, exacerbating the dilemma. Now imagine a world in which construction is net zero emissions, shelter is strong and affordable, and waste is minimized. This is the future we're pursuing with our research on sustainable wallboard production. Drywall's become synonymous with modern construction, and I'm willing to bet if you look around the room you're in now, it's probably made of walls from drywall. Unfortunately, while it's easily mass-produced and utilized, its production is catastrophic for the environment. It starts with mining the raw material, gypsum, or calcium sulfate dihydrate out of the ground. This is then heated up to a very high temperature in order to achieve a chemical reaction. After this, it's rehydrated and put on a plane to form a wallboard, which is finally dried to get our final product. Unfortunately, this process uses gas-fired heaters to achieve that high temperature, which produces over 12 million tons of carbon emissions every year. And also the rehydration isn't optimized for the process, so it consumes 54 million tons every year. It's both inefficient and wasteful. We wanted to reimagine this system as a more sustainable process. So the first thing we do is we're looking at replacing this gas-fired heater with electric heating. And the second is we can optimize this rehydration so that it only takes what's necessary for the actual process. This is exactly what we've done. We're looking at radio frequency heating, which relies on electromagnetics and has the same operating principle as your microwave at home. It takes an electricity and converts it into waves that vibrate the molecules within the sample. This then creates friction, increases the temperature, and triggers that chemical reaction. Now this has a few key benefits. First, it's higher efficiency, and second, it creates a more uniform product as all the molecules are heated evenly. It consumes less energy, and most importantly, since it relies on electricity, it creates zero on-site carbon emissions. Over the past 3 years, we've conducted hundreds of experiments to understand this unique phenomena. By monitoring the temperature and the reaction extent across time, we've seen some incredible results. In fact, we've achieved over 90% effectiveness in creating drywall, which is the same as the current combustive process. Overall, when we look at the whole project impact, by replacing the gas-fired heaters with radio frequency heating, we can reduce those 12 million tons of carbon emissions every year by 75%, and the 54 million tons of water wasted every year by 50%, down to 3 million and 27 million respectively. And unlike much scientific research that just ends in the journal paper, this is actually being implemented by our partner, Saint-Gobain, who's the world leader in drywall. Now, you might be thinking, surely these carbon neutral walls aren't going to stop global warming. 9 million tons of carbon emissions reduced isn't going to prevent sea levels from rising. And that's true, but our research doesn't stop here. See, there's so many other manufacturing industries that rely on the same heating process, like iron, steel, concrete, and clay. Each of these could achieve carbon neutrality by swapping from gas-fired heating to electromagnetic or radio frequency. Even the lithium-ion batteries in our electric cars that are the future of the automotive industry, they can rely on this process. So in conclusion, our research has demonstrated two things: that RF heating is a viable alternative to manufacturing, and it's a sustainable alternative to manufacturing. The transition to electric heating represents a significant step forward in reducing the environmental impact of the construction industry. By embracing this technology, we can build a better future, one wall at a time. Thank you.